Okay, today we'll be talking about comparing and ordering whole numbers. To compare whole numbers, we use symbols called inequality symbols. Here you'll see that we have a less than symbol and we have a greater than symbol. We would use the less than symbol in situations like 3 is less than 4. Greater than we would use just for the opposite, so maybe 100 is greater than 15. The way that I remember which symbol is which and how to read them is less than. The symbol kind of looks like a squished L, and less than starts with an L. Occasionally our numbers will be equal to each other, and in that case we would use an equal sign. For instance, 300 is equal to 300. And an equal sign is not considered an inequality symbol because inequality symbols are literally in equal, not equal. All right, let's put those symbols to work. The first example we have is 19,000 and 40,000, and we need to fill in that blank with a less than, equal to, or greater than symbol. One way to compare these two numbers is to line up the numbers by their place value. So if we have 19,000, we're going to line up 40,000 so that all of the place values are lined up accordingly. So here you'll notice we have our 10,000s. Here we have our thousands, 100s, tens, and ones. Starting with the largest place value, compare the two numbers. Here we have a 1 in the 10,000s place in 19,000, and we have a 4 in the tens place in 40,000. Of the two, the 4 is larger, so this entire number is larger than 19,000. So you would use the inequality symbol. That means that 40,000 is bigger than 19,000, and your answer is 19,000 is less than 40,000. Okay, let's work on another example. Here we have 2,195,000 compared to 986,000. We're going to again line up our place values. So we have our first number. Now you'll notice that there are no digits in the millions place. So make sure that you are in fact lining up the 100,000s here. Okay, now compare from left to right. You'll notice that there are 2 millions in this first number, but there are no millions here, almost like an invisible zero. So when you compare these two numbers, 2,195,000 is definitely greater than 986,000. On to our final example, you'll notice that these two numbers are actually very similar looking, so we have to be careful when we're lining up our numbers here. We have 123,445,700 versus 123,445,720. Now we're going to look at one place value at a time. You'll notice the ones are the same, so that's not helpful. The twos are the same, threes, fours, fives. We have sevens in both of our hundreds. And then here is where we have a change. You have 0 versus 2. Of the two numbers, 2 is larger, so that means that this number along the bottom is going to be larger than the number above it. So when we plug in our symbol, we find that this number is right here, 123,445,720 is bigger, so your inequality symbol wants to eat that number, and there we are. Some people prefer to compare numbers by reading them from left to right based on place value rather than lining up the place values. Our first example is 72,100 versus 72,300. Now, if we look at our place values and compare one at a time, you have a 7 in the 10,000s and a 7, so disregard those. We have a 2 in the thousands place, and we also have a 2 in the thousands place here, so we can continue on to the next place value. We then have a 1 in the 100s place, and we have a 3 in the 100s place. So we would plug in a less than symbol, reading 72,100 is less than 72,300. For the next example, we have 196,122,000 compared to 196,300,000. One place value at a time. 1 compared to 1, they're the same, move on. 9 compared to 9, again they are the same, so we go on to the millions place. Here we have a 6 compared to a 6, again the same, move on to the hundred thousands. And finally we find that we have a 1 compared to a 3. We know 3 is larger, so this number is bigger. Have your inequality symbol eat the larger of the two numbers, and you are finished. Alright, using one of the strategies we just discussed, complete the 3 exercises below, filling in the blank with a less than or greater than symbol. Pause the video and I will fill in the answers for you, and you can compare your answers and see if you got them correct. Okay, for the first problem, if you line up the place values, you find that from the very beginning here, in the 10,000s place, we have a 1 and we have a 2. So you know that 20,000 is going to be greater than 10,000. So your answer is less than. In the second problem, line up your place values again. Here you have a 3 in common, you have 1s in common, you have 0s in common. So we can disregard those digits. Now look at this place value right here. We have a 0 compared to a 2 in the thousands place. A 2 is larger, so this number is larger. And we will plug in our inequality symbol so that that number is greater. So we have 3,100,876 is less than 3,102,000. And on to the final problem, we have 15,999,123 compared to 15,998,123. These numbers look almost identical, but when we look at the place values one at a time, same, 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 we find that there is a difference right here with the 9 and the 8. The 9 is a little bit bigger, so that means that this top number is going to be larger, and the top number is reflected right here. So have your inequality eat the larger of the two numbers, and 15,999,123 is greater than 15,998,123. Alright, now we have everything we need to order our whole numbers from least to greatest or from greatest to least. Looking at this first example, we have been given 5 numbers and we need to compare them, so list those according to place value. 565, 499, 555, 665, and 566. Now we're going to compare from the left to the right, looking at the hundreds place first. Now we're trying to list from least to greatest, so we're looking for the smallest number first. And the smallest number in the hundreds place is 499, so that's our smallest number. Then we have 3 numbers that have a 5 in the hundreds place. So we need to move on to the tens place to compare those numbers. We have a 6, we have a 5 in the tens place, and we have a 6. Of those 3 numbers, 5 is going to be the smallest, so that's our second smallest number. However, we are not finished comparing the 500s, so we need to look at that tens place because we had a 6 in common here and a 6 in common here. Finally, in the ones place, we have a 5 here and we have a 6 here, so this number is slightly smaller. So that would be our third number listed. That makes this the fourth. And finally, of course, if we have a 6 in the hundreds place, it's the largest. That will be our fifth number. So when we list these from least to greatest, we actually need to write out the numbers. We have 499 as our smallest number, 555, 565, 566, and 665. Okay, and let's do the same thing for this next example. We have 7,160, 7,610, and 7,060. first compare your biggest place value, which here is thousands place. Here they are all the same, so we're going to move on to the hundreds place. And when we compare our hundreds place, we have a 1, a 6, and a 0. Now be careful, the directions here say list the following numbers from greatest to least. So, of these numbers, 6 is the biggest in the hundreds place, so that will be our first number listed. 1 is our second, and then finally 0 is our smallest of the numbers. List the numbers out just like we did before, so our answer is going to be 7,610, 7,160, and 7,060. On your own, complete the following problems. List these numbers from least to greatest, and in the second problem, greatest to least. Pause this slide, and then in a few minutes when you're finished, hit play, and I will show you the correct answers. Okay. Here below you see that I have listed our numbers based on place value. In the 10,000s place, only one of these numbers has a digit in the 10,000s place, so that will be our largest number. So this will be listed last because we're listing from least to greatest. Now comparing the other two numbers, they both have a 9 in the thousands place, so we're going to move on to the hundreds place. Here we have a 0, and down here we have an 8. So that means that this first number is actually the smallest of our three, and the final number is a little bit bigger with an 8 in the hundreds place. So our answer for the first problem is 9,001, 9,880, and 19,000. All right, and our final problem, I lined up my numbers again as I have before, and I'm going to compare from left to right. Here, the only digit that is in the 100,000s place is the 1 in 108,000, so that's going to be my largest number. I'm going to list that first because we're going from greatest to least this time. Now, if I move on to the 10,000s place, the largest number I have is this 9, so 99,000 is going to be the second number I list. Then I move on to the thousands place. You'll see that of the two numbers I have left, I have an 8 here, and I have an 8 here in the thousands place, so that is not helpful. Continue on. We have a 0 and another 0. We have a 0 in the tens place and a 0 in the tens place here, so finally we look at that very last place value, and we have a 0 and we have a 1. So that number is slightly bigger. That will be the third number we list. And finally, the last number is going to be fourth. So our final answer is 108,000 as our largest number. Then 99,000 as our second largest number, 18,001, and 18,000. Okay, and you guys are ready to go for class tomorrow.